What if everything we thought we knew about objects from beyond our solar system was wrong? On the 29th of October, 2025, an interstellar wanderer, dubbed 3IATLAS, made its closest approach to our Sunday, but instead of behaving as expected, this cosmic visitor unveiled a startling anomaly. This unprecedented event sent astronomers worldwide into a frenzy, desperately searching for answers. And the revelations emerging from their investigations are compelling certain scientists to ponder inquiries they once considered unimaginable. We're not just discussing yet another ordinary comet merely traversing our solar system. No, this concerns a celestial body that journeyed for billions of years, navigating the profound voids between distant stars. It's an entity whose current conduct defies established celestial norms. And with every new piece of information we acquire, its mysterious nature only deepens. Allow me to shed light on the unfolding events right at this very moment, because recent developments have profoundly altered our entire comprehension of this enigmatic visitor. Upon 3I-ATLAS's approach to Perihelion, its closest rendezvous with our Sun, a truly extraordinary incident unfolded. The comet's luminosity didn't merely intensify by degrees as predicted. Instead, it underwent a sudden dramatic outburst. Its brilliance escalated at double the pace it had previously maintained. Indeed, it was twice as rapid. Chi-Chang Zhang of Lowell Observatory and Carl Badams from the United States Naval Research Laboratory meticulously chronicled this startling occurrence, as it happened, yet found themselves without an immediate explanation for the unfolding spectacle. Pause and consider that profound implication. This particular celestial body has been journeying across the vastness of interstellar space for potentially billions of years. Throughout its epic voyage, it has traversed cosmic environments that defy our wildest imaginations. Yet upon nearing our Sun, it abruptly displayed a level of activity far exceeding any prior scientific prediction. The pressing question remains why. Subsequent spectral analysis unveiled a truly captivating insight. Intriguingly, the comet's emitted light registered as bluer than the Sun's characteristic spectrum. This noticeable blue shift serves as a clear indicator of carbon molecules, notably diatomic carbon C2 and specific emitogen compounds NH2. Such readings are distinct fingerprints of an ongoing, vigorous process of ice sublimation. However, a deeper look into the specifics reveals an even more unsettling truth. Radio telescopic data indicated that merely 2 weeks prior to Perihelion 3I-ATLAS was shedding an astounding 5.7 times 10 to the 28th power water molecules each second. This emission rate was 40 times higher than what was recorded only 1 month before. Imagine 40 times the usual volume of water gushing into the cosmic void, a spectacle vividly likened by one scientist to a fire hose on full blast. At this juncture, you might reasonably presume this to be typical cometary behavior. Indeed, as comets draw near the Sun, their icy constituents vaporize, leading to increased luminosity. This aligns with standard astrophysical principles. However, 3I-ATLAS appears to defy these very principles. The observed pace of transformation is simply inconsistent. The temporal sequence is out of sync, and the phenomena we are witnessing bears little resemblance to what we understand about comets originating within our own solar system. This is precisely where the unfolding narrative takes a compelling twist. During this pivotal celestial phase, sophisticated space-based observatories, including SOHO Stereo A and the recently deployed GOES-19 satellite, each outfitted with specialized coronagraphs designed to scrutinize objects near the Sun, successfully captured images of 3I-ATLAS. And what they saw was unusual. The comet manifested as a subtle yet distinctively elongated luminous point. But the truly perplexing detail, there was no discernible dust tail whatsoever. Absolutely none. Instead, what observers noted was merely an expansive, ethereal luminosity conspicuously devoid of the typical dusty plume comets invariably emit. What profound implications does this singular absence hold? Some scientific hypotheses suggest that early on, carbon dioxide gas was effusing from the comet when it was approximately 3 astronomical units away. This CO2 emission would have served to cool the nucleus's surface, effectively creating a shielding stratum that inhibited the sublimation of water ice. However, at a certain juncture, something pivotal shifted. That shielding stratum eventually diminished, and once it did, the underlying water ice became abruptly vulnerable to the sun's direct, unmitigated radiation. The immediate consequence was an eruption of intense luminosity and heightened activity. Yet another intriguing alternative presents itself, and it is at this very point that certain researchers encounter a degree of professional disquiet. The very makeup of 3I-ATLAS's nucleus could in fact diverge radically from any previously observed celestial body. It's vital to recall this enigmatic object did not originate within our solar system. Instead, its genesis occurred within the gravitational embrace of an entirely different star amidst a distinct stellar milieu under unique chemical conditions. What if its inner architecture bears no resemblance whatsoever to the comets we commonly observe? What if concealed within its very nucleus lies an element or mechanism that remains entirely beyond our current comprehension? The powerful James Webb Space Telescope has been diligently scrutinizing 3I-ATLAS, and its findings have introduced yet another enigmatic dimension to this cosmic riddle. The telescope's near-infrared spectrograph unveiled that this particular comet has undergone a profound metamorphosis shaped by billions of years of relentless cosmic ray bombardment. To clarify, we're referring to galactic cosmic rays, extraordinarily high-energy particles that saturate interstellar space, continuously impacting the comet's surface over unimaginable stretches of time for eons. Research spearheaded by Romain Maggiolo from the Royal Belgian Institute for Space Aeronomy indicates that these cosmic rays have fundamentally re-engineered the very physical and chemical composition of 3I-ATLAS. Sophisticated computer simulations propose that these cosmic rays have permeated approximately 50 to 65 feet deep into the comet's surface, thereby forging what scientists term a deep irradiated crust. This outer crust now bears little resemblance to the initial untouched matter from the comet's parent star system. It has been relentlessly processed by radiation over such an immense cosmic duration that its very essence has transformed into something altogether new. Herein lies a pivotal shift in our scientific understanding. For years, scientists harbored aspirations that interstellar phenomena such as 3I-ATLAS would offer an invaluable glimpse into alien stellar systems, allowing us to scrutinize these enigmatic wanderers and deduce the prevailing conditions around faraway suns. Yet if Maggiolo's hypothesis holds true, then what we are currently observing is not an untouched specimen from an extraterrestrial star system. Instead, it is a profoundly altered, radiation-sculpted outer layer, irreversibly reshaped by its arduous journey across the vast expanse of interstellar space. Maggiolo articulated a statement that truly gives one pause. He posited that 3I-ATLAS has effectively become a creation of its interstellar odyssey rather than simply a remnant of its original cosmic birthplace, at least in its superficial composition. This inherently prompts a most evident inquiry. What profound secrets might be harbored beneath that deeply irradiated outer shell? Could there be an untouched primordial substance concealed within this object's very core, a relic from its Genesis star system? And here is a profound piece of information largely unknown to the general public. Professor Avi Loeb, the esteemed former chair of Harvard's astronomy department, has officially petitioned NASA to make all scientific data concerning 3I-ATLAS accessible to the public domain. One might reasonably question the rationale behind such an extraordinary request. What elusive insights does he suspect are contained within that unreleased data from NASA 3IATLAS's post-perihelion behavior has now become the epicenter of rigorous scientific examination. Leading scientists candidly acknowledge their uncertainty regarding future developments. Will its striking brilliance persist in its upward trajectory, or might it abruptly diminish? Zhang and Badams, in their detailed observations, specifically remarked that the comet's subsequent evolution after perihelion could prove to be equally as anomalous as its preceding explosive outburst, perhaps even more profoundly perplexing. And it is this very unpredictability that elevates the current juncture to such a critical status. We are currently observing in real time an interstellar entity behaving in ways that utterly defy our complete scientific explanation. During its closest solar approach, 3I-ATLAS attained a visual magnitude of approximately 9. This level of luminosity is sufficient for observation via modest amateur telescopes, provided one possesses precise positional coordinates. However, a significant challenge arose. Its celestial placement in our sky was so proximate to the Sun that terrestrial observation during that critical interval was rendered nigh on impossible. Consequently, our understanding hinged entirely upon data furnished by space-based coronagraphs. The visuals they provided depicted a celestial body bearing no resemblance whatsoever to a conventional comet. The photographic evidence showcased an extended radiant morphology, strikingly devoid of any anticipated dust tail. Instead, the observed phenomena suggest a predominant emission of gaseous material. The distinct hydroxyl glow, a telltale sign of water vapor being expelled from the comet, was successfully recorded by NASA's Swift Ultraviolet divided by optical telescope. But this palpable absence of a visible dust tail presents a significant anomaly. Typically, comets generate dust, an essential component contributing to the spectacular display of their tails. Thus, the perplexing query remains: what accounts for the missing dust from 3I-ATLAS? One plausible theory posits that its fundamental composition is predominantly ice with an exceedingly minimal proportion of solid matter capable of generating dust. However, even this does not entirely account for the sudden explosive surge in brilliance. A second, more unsettling hypothesis, prompting considerable unease among certain researchers, is that the object's intrinsic architecture defies any prior categorization known to humanity. We now turn our attention to the revelations from the James Webb Space Telescope, for this is the point where the narrative veers into conceptual realms, directly challenging our fundamental assumptions concerning interstellar objects. The Webb telescope had previously scrutinized 3I-ATLAS in August prior to its perihelion trajectory. Its near-infrared spectrograph meticulously analyzed the electromagnetic radiation emanating from the comet, specifically identifying the wavelengths that unequivocally indicate the presence of particular molecular species. The collected data substantiated an earlier suspicion that preceding observations had subtly suggested. This comet is notably abundant in carbon dioxide. Indeed, its carbon dioxide content is exceptionally high. Crucially, however, Webb's profound analysis illuminated that this object's exterior layers have undergone a fundamental metamorphosis due to prolonged exposure to cosmic radiation. To elaborate on the implications of this finding, within our own solar system, a formidable protective bubble known as the heliosphere is perpetually generated by the ceaseless solar wind emanating from our star. This heliosphere acts as a vital guardian, largely deflecting the majority of galactic cosmic rays. These are intensely energetic particles originating from cataclysmic supernova explosions and other turbulent cosmic phenomena throughout the galaxy. Conversely, in the desolate expanse of interstellar space, such protective shielding is entirely absent. Any celestial bodies traversing the voids between stars are subjected to the unabated full intensity of cosmic ray bombardment, enduring this relentless assault for millions or even billions of years. Sophisticated computer models crafted by Maggiolo and his team, and building upon prior investigations of comets native to our local system, simulated the profound alterations experienced by ice and rock when subjected to cosmic rays over prolonged eras. The simulation vividly illustrated that subsequent to approximately 1 billion years of incessant radiation, the internal transformation reaches its final conclusive stage. The outermost strata of the object transmute into a distinctly different substance. Carbon monoxide molecules undergo a chemical conversion to form carbon dioxide. Furthermore, the crystalline lattice of the ice itself undergoes a structural modification. Existing chemical bonds rupture, subsequently re-establishing themselves in novel atomic arrangements. The outcome is a durable crust extending approximately 50 to 65 feet into the comet's subsurface. This protective outer shell, comprised of radiation-processed matter, no longer accurately reflects the primordial makeup of the comet's parent star system. And now for the truly disconcerting aspect of this revelation. Our current understanding offers no definitive measure of this crust's true depth. We remain uncertain if solar thermal energy will gradually erode it, ultimately exposing untouched material below, or if the entire celestial body has undergone complete transformation permeating its very core. Maggiolo explicitly articulated that researchers must meticulously factor in these extensive aging processes when undertaking any analysis of 3IATLAS. One cannot simply presume to be examining an untainted specimen hailing from an alien stellar system. What confronts us is an entity fundamentally reshaped by the relentlessly unforgiving conditions of deep space. Yet he also conveyed a message imbued with a sense of optimism. Loeb stated that 3IATLAS retains immense scientific intrigue, even with this added layer of complexity. This is because, if we can decipher the formation mechanisms of its radiation crust, and subsequently contrast pre-perihelion observations with those captured afterward, when solar erosion might have unveiled deeper strata, we may yet gain a fleeting insight into its pristine original composition. Such an opportunity represents the current focal point of scientific anticipation. The comet has successfully navigated its perihelion and is presently receding from the Sunday. Consequently, throughout November and December of 2025, that is right now, it will once more become discernible from Earth, continuing its outward trajectory beyond our solar system's confines. This brief period constitutes our singular observational window. It is now that we might ascertain whether the intense solar heating has sufficiently eroded the radiation crust to expose any underlying hitherto hidden constituents. However, parallel to these phenomena, another unusual occurrence is transpiring. This new development doesn't readily conform to the established understanding of cometary behavior. Susanne Falser, a distinguished professor at Forschungszentrum Jülich in Germany, has advanced a radical proposition concerning interstellar objects such as 3IATLAS. Her theory intimates that these celestial bodies might transcend mere cosmic detritus. Indeed, they could well represent the primordial seeds from which planets eventually germinate. Her computational models demonstrate that nascent stars encircled by their planet-forming disks of gas and dust possess the capability to gravitationally entrap millions of interstellar objects as these traverse the galaxy. Upon their capture, these substantial objects, already measuring hundreds of meters in extent, could then function as the foundational nuclei facilitating the development of planets. This innovative concept offers a resolution to a persistent enigma within the realm of planetary science. We understand that planets coalesce via accretion, wherein minuscule particles progressively adhere to form increasingly massive entities. However, a noticeable lacuna persists in our current theoretical framework. Computer simulations demonstrate that when objects attain an approximate diameter of 1 meter, the turbulent conditions of a protoplanetary disk ought to instigate their collision and fragmentation rather than promoting cohesion. The conundrum, therefore, is how to bridge the evolutionary gap from meter-scale rocky fragments to fully fledged planet-sized celestial bodies. Falser's proposed solution is elegantly straightforward. One does not commence the process with meter-sized. If you find this content interesting, please like and leave a comment. This video from Cosmic Warning A to Z. Thank you for watching.